Hello and welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager here at InfoQ and Product Architect at DataWire. And I recently had the pleasure of sitting down with Joe Duffy, founder and CEO at Pulumi. I'm sure many of you have heard of the concept of infrastructure as code, but if you're anything like me, this often makes you think about configuring cloud infrastructure via bash scripts, HCL or YAML. The open source Pulumi project has taken a different approach to this, and it enables engineers to write infrastructure as code in one of the many supported application languages like TypeScript, .NET or Go. I was keen to ask Joe about how all this works and better understand how this allows engineers to use their familiar language constructs and also their tool chains when defining infrastructure. I was also keen to pick Joe's brains on a number of associated subjects, such as how should engineers collaborate and share infrastructure as code, how should we test this kind of code, and what does a continuous delivery pipeline look like here. And finally, as I work a lot across multiple clouds myself these days, I was also keen to learn about Joe's thoughts around the future of multi-cloud and hybrid cloud, and how this may be supported with something like Pulumi. So hi Joe, welcome to the InfoQ podcast.
Hey Daniel, it's great to be here.
Could you briefly introduce yourself and share a bit about your background for the listeners, please?
So my name is Joe Duffy. I'm the founder and CEO of Pulumi, which is a infrastructure as code startup here in Seattle, Washington. My background, I was at Microsoft before. I did some things before that, but most people know me from my work there, where early engineer on the .NET framework, did a lot around developer tools, kind of worked on this distributed operating system called Midori and helped with the .NET open source project. So a lot of the .NET folks know me pretty well. So I've been focused on the cloud space for basically the last 3.5 years.
So I'm keen to dive in a bit more about Pulumi today. But before we get there, I always like to look into the problem space we're in. So infrastructure as code's been around for a while, but could you briefly give an outline for the listeners as to what problem infrastructure as code is trying to solve?
Yeah, it's a great question. I think, infrastructure as code really is helping you to automate the provisioning and management of your cloud infrastructure. And, why is that necessary? You imagine, if you're just getting started with the cloud, the obvious thing to do is to go into the AWS console and point and click and spin up some virtual machines and start that way. And that's a fine way to explore. But, what happens if you accidentally delete something or you want to create a second copy of your infrastructure because you want to actually go into production or have a staging environment? And, at scale, you need, an automated solution for, provisioning, managing this infrastructure. And so infrastructure as code is a way to do that in code rather than having to do, CLI commands or bash scripts. You really use code to manage your infrastructure. And there's a variety of solutions, from markup-based solutions like YAML or JSON through, like Chef and Puppet in the early days doing configuration management using Ruby or Ruby-based DSLs. And, there's a variety of different approaches. Pulumi takes an approach of using general purpose languages to do provisioning of your infrastructure.
How would you say that Pulumi is different from, say, things like Puppet, Chef, Ansible?
Yeah, I think, the configuration tools, and really I split the infrastructure as code space into configuration and provisioning. So provisioning is about creating and updating and versioning the infrastructure itself, like the virtual machine. A lot of the configuration tooling like Chef, Puppet, and Ansible is more about what's happening inside of the virtual machine. So, right, you spin up some virtual machines, and then what do you have? We have to install some packages, right? You want to, configure services like systemd kind of, configuration, or you want to patch the servers, right? Like a new version of the web server comes out, you want to go and, basically SSH into the machine and patch it in an automated manner. Over the years, especially as we've adopted containers and serverless and the infrastructure itself has become more fine-grained, you think of all the IAM roles and policies and all the moving pieces, provisioning is actually kind of more interesting nowadays than configuration. Also, there's this other trend, which is immutable infrastructure. If you want to deploy a new version of your web server, one approach is to patch your server. But then you have to think about all the n to n plus 1 possibilities of, what is the current state of the server and how do I appropriately move it to the new desired state. With immutable infrastructure, you can say, hey, no, I'm just going to spin up a new web server, redirect all the references to the new web server, and then destroy the old one. And so we see a lot of people moving to that model with provisioning tools instead.
So how does Pulumi, say, differ from things like, say, Terraform or CloudFormation, things that are kind of declarative in nature? Pulumi, I'm guessing, is imperative.
It is, but it has sort of a declarative core to it. I think that's the special thing about Pulumi. If you think of, a lot of people are familiar with Bodo, for example. You can just write a Bodo script, write some Python code, go out to the AWS SDK and make a bunch of calls and spin up servers, and you can do all of that. The key thing that a Terraform and a CloudFormation and now Pulumi do is it's based on the notion of this goal state. right? So your program, when you run it, actually says, hey, you know what I want? I want a VPC and these subnets, and I want an EKS cluster, and then I want an RDS database. And then it specifies that so that the deployment engine, whether it's Terraform, CloudFormation, or Pulumi, now can say, okay, that's your desired state. I'm going to make that happen. I will carry out the deployment. And so that works for the first time you've done it, but then in subsequent deployments, maybe you want to scale up the number of node pools in your Kubernetes cluster from 2 to 3. Now the infrastructure as code tool, because you've declared that new goal state, it can sort of produce a plan. It can diff that with the current known state and say, okay, you just added one new node pool. I see that you declared all this other infrastructure. The only difference is this one node pool. So the declarative part is essential. What Pulumi does is it allows you to express your goal state using an imperative language. And so the goal state itself is still declarative. It declares your desired state. You're just using for loops and functions and classes and all those familiar constructs to declare it. I also mentioned we support .NET, so you can actually do this in F#, in which case it's more of a functional approach, which a lot of folks, it's kind of fun and interesting, completely different way of thinking about your infrastructure.
That sounds intriguing. So I'm definitely keen to dive into that a little deeper in a minute. First off, say folks are new to Pulumi. What's the thing they do? Do they install something? Do they have some kind of compiler?
Yeah, so Pulumi is an open source tool. So, you can download it. It's all up on GitHub, open source. The whole SDK is open source. And so you would download it. It's a CLI. The CLI hosts an engine, and the engine knows how to interact with the different language runtimes. And so you basically download this tool, and then you say, hey, I want to create a new project in Python or JavaScript or whatever your language of choice is. And then the Pulumi engine knows how to spawn the language, runtimes and do all of that. So it's pretty simple to get started. We also, for state storage, so this is another kind of facet of infrastructure as code, we have a hosted service that we make available for free that you can use. You can opt out of it if you don't want to use it, but it's just super convenient because you don't have to even think about, state management, which is kind of a fascinating topic. Like if you use CloudFormation, it feels like there's no state management because CloudFormation is in AWS, and so they're just managing the state for you. It turns out there is state behind the scenes. Terraform is an offline tool, and so it kind of gives you the state, and then you have to manage it. And if you do that wrong, you can shoot yourself in the foot. So we tried to do Pulumi more like sort of the CloudFormation model than Terraform. But if you want to take your state and go, you can do that as well.
You mentioned a bunch of languages there. What languages does Pulumi currently support?
Yeah, so we support Python. We support any Node.js language. So most people use TypeScript or JavaScript. We support Go, which is actually fun because it's great for embedding infrastructure as code inside of larger systems. And then we also support .NET. And so any .NET language, which includes C#, F#, Visual Basic, even COBOL.NET if you want.
Nice.
We don't see much of that these days.
So you mentioned about defining infrastructure using the F# functional language. How exactly does that work?
Functional languages themselves are declarative in a sense, right? Because you don't have mutable state. Functional languages just compute new states out of old states. And F# itself has had notion of these workflows for a while. Actually, back in the early days of async programming, we had these F# workflows. And so actually declaring your infrastructure actually feels like sort of declaring a workflow of how all these infrastructure pieces relate to each other. Ultimately, all these languages interact with the Pulumi engine in fundamentally the same way. It's just really the syntax of how you're describing your infrastructure and the facilities of the language that you have available to you.
So I guess you can do things like modules and like libraries, that kind of thing, yeah?
Exactly, which is great because, how many times have you written the same 2,000-3,000 lines of CloudFormation or Terraform to spin up a virtual, VPC in Amazon? Well, now you can stick that in a package and share it with your team, share it with the community, or just reuse it yourself, next time you need it.
So diving in a little bit to how Pulumi works, is it somewhat like a transpiler? Is it literally, say, taking TypeScript, for example, transpiling it into like API commands for Amazon or for Azure, or how's that kind of working?
Yeah, it's fairly complicated, and I'll say it took us, 4 attempts to get it right. And we started actually writing our own language runtime because of some of the challenges. The challenge you have is, what if a resource depends on another resource in your program? You need to capture that as a dependency so that as you're provisioning things, you do it in the right order. As you destroy resources, you do that in the right order, while also maximizing parallelism during the deployment so your deployments happen as quickly as possible. So in Pulumi, in the code, you're basically declaring a DAG, basically a graph of resources that depend on each other. And then the Pulumi runtime takes that, creates a plan out of it, It actually lets you see the plan before you've applied it. So you can actually see the full set of changes that will happen before you actually carry them out. And that works the first time, but also, diffs. So you get this nice, it's almost like a Git-like diff view of the resource states. And then you can choose to apply it. And you can run these as separate steps as you want. When you choose to apply it, Pulumi takes that plan and then orchestrates all the AWS SDK calls or Kubernetes or whatever cloud you're using.
What backends, I guess, do you support? You mentioned a couple there. I presume you support all the major clouds. You mentioned Kubernetes.
Yeah, so all the major clouds, AWS, Azure, GCP, also Alibaba Cloud and other DigitalOcean, for example. But we do support Kubernetes, which is actually a really popular package for us. The full object model in Kubernetes is available. And so you can actually not only provision the Kubernetes clusters using Pulumi and you install services into them using Helm charts, for example, you can also write your application config in the same model. You can actually have dependencies between these things, which is nice because oftentimes, provisioning a new Kubernetes cluster, you actually have to spin up, let's say, EKS, provision some AWS resources like CloudWatch, logs, and then install maybe some cluster services using Helm. And all these things have to sort of, have a delicate dance. Pulumi, you can actually provision resources across all these clouds using one program, and Pulumi will orchestrate it kind of in the right order.
Is Pulumi somewhat similar to things like AWS CDK? They've got their, I think it's Cloud Development Kit. I bumped into that a few times I've been using Amazon. Is there somewhat of a similarity there?
A lot of similarities. We came out, a little bit before CDK, so we've had a bit more bake time. But the main difference, I think, is the multi-cloud nature. We support Kubernetes, we support Azure, GCP, also support on-prem technologies like, vSphere, OpenStack, F5, Big IP. So it goes beyond just the cloud providers. I'll say the other difference, CDK is a transpiler. So you asked me, is Pulumi a transpiler? It turns out Pulumi is actually a runtime, and that it's a subtle point, but ultimately, at the end of the day, CDK spits out CloudFormation, which is YAML. And if you have an error, tracing that back to the program isn't quite, as first class. It's great work, though. I love what they're doing, and I love that they are taking the idea of infrastructure as real code and seeing the same sort of vision, the future that we see. So we love that. We're friends with those, the CDK team, and we actually talk with them a lot about our experiences. And so it's been a great partnership, but there are some fundamental differences.
I do like that you mentioned there about debugging some of this stuff. It's something I've struggled with, like even in Java, say when I'm messing around with bytecode, how do you trace it back to the thing I've written in Java, say? So how does sort of debugging work with Pulumi, I guess? Say there is like an infrastructure issue. Can I trace it back to the Pulumi code I've written?
Yeah, so we have sort of what I'll call, I'm probably dating myself, but like PDBs. I used to manage like a C++ team at Microsoft, and we spent a lot of time making sure the debugging symbols, mapped back to the source code. We sort of have the equivalent of debugging symbols for your infrastructure, where you actually know exactly where the infrastructure came from down to the actual program source code. And because we're using general purpose languages, you can just use your favorite editor, your favorite IDE, your favorite debugger, your favorite test tools. So actually, the language is like the surface area obvious difference. The tool chain and the ecosystem that you get access to by virtue of using that language is actually almost more powerful. It's that second order effect.
Is there any disadvantages with using something like Pulumi?
I think some people are uncomfortable with a full-blown language to start. I think it takes a while for people to get comfortable, especially if you're coming from a world of these limited DSLs or limited YAML dialects. A lot of folks are a little afraid. They're like, well, what if you're creating like, web server factories of factories and you kind of an architect astronaut and like creating these huge layers of abstractions and now it's like totally nobody can understand what's going on. I think, those same arguments, in my opinion, apply also to application code, and we've somehow figured it out there. So I don't worry as much, but it's a reasonable concern for folks to have. And, not everybody understands full-blown languages, right? And so there is a learning curve if you're coming, but I think a lot more people these days, are getting trained on languages. A lot of folks, graduating from schools kind of understand Python. They understand these things. So I think it just makes it more accessible overall. And so I think ultimately it is better for folks to kind of learn and maybe go outside their comfort zone a little bit. And I think you'll come out the other side, better off.
Interesting note there, as in, I'm guessing Pulumi is mainly aimed at developers as opposed to operators, although that, to be honest, increasingly that boundary is blurred these days, in my experience in particular. But I'm guessing, yeah, like some operators I've worked with, fantastic folks, really deep understanding of the tech, but were a lot more comfortable with simple scripts than, say, a full programming language. And I was almost the opposite. I liked the full programming language, wasn't comfortable with the OS at times. So I'm guessing Pulumi is kind of skewed towards developers.
It's been interesting. I thought that was going to be the case, and it turns out where resonating the most is actually I&O infrastructure ops teams who have used Chef and Puppet. They have, used Bodo scripts. They're comfortable with Python. They've maybe used Terraform enough to understand, some of the limitations they're hitting. So for developers, for sure, it's a no-brainer. But for folks that are already doing infrastructure and also who want to work better with their development teams, that's the other trend we're seeing is we tend to have these silos sometimes. And, DevOps as a movement, we've helped to break some of those down, but we still see a lot of infrastructure teams who want to give more control to their developers, and they just don't know how, right? Like the development team doesn't want to use a YAML templating thing. They want to use their favorite language. So this gives them a way to have that conversation and empower them a little bit more.
So let's look at the workflow stuff now. So you've already mentioned about the power of diffing, which I think is really powerful. How does collaboration in general with Pulumi work? I'm guessing I'm diffing my code and I'm diffing the plans as well.
That's right. So it really depends, varies by team. I think, especially if you're inner loop, you're just bringing up a new service, you're just, doing initial development. A lot of times that happens at the command line. And at the command line, our CLI shows you the full diff. You can kind of drill into the details. You run the command, we call it Pulumi up, and Pulumi up will basically do the preview, show you all the difference, the plan, and then you can say apply, and it will go and carry it out. I think in production settings, a lot of people are moving more towards this world of Git-based deployments, where we actually integrate with your source control system. So if you're using GitHub, for example, when you open a pull request, Pulumi will actually augment the pull request with the full diff of infrastructure changes. So now in the pull request, you can say diff the code, but it's not always evident when you're diffing the code, like what is the actual, deployment going to do. So it'll show you, hey, if you were to deploy this, it's going to, create a new web server, modify a Route 53 record, et cetera. And then that links over to Pulumi so you can actually drill in. And now you can have a conversation and a review process in your team around rolling out changes. And that's actually how we manage our own online service.
So how will I go about testing Pulumi code? Because as a Java developer, again, or probably any developer really, I'm often doing unit tests, then I might do some kind of component test, and then integration, then, pre-production, production tests. Is that workflow somewhat similar with Pulumi?
Exactly. And I think you nailed it on the head there, that there's a lot of different kinds of testing. So when you say testing, you could mean unit testing. It could mean integration testing. There's also policy. We have policy as code. So enforcing that you didn't violate some team policy. One of the more interesting kinds of testing we see is ephemeral environments where, let's take the workflow we were just talking about in the pull request. A lot of times, the Pulumi CLI makes this easy to do. You can say, hey, spin up an entire new copy of my infrastructure, run a battery of tests against it, and then tear it all down and post the result back to my pull request as, did it pass or fail? So really unlock some new workflows there. But because it's general purpose languages, you can use your familiar unit test frameworks. You don't have to learn a bunch of new tools and techniques.
You mentioned about spinning up ephemeral environments. I've done this a few times in the past. One challenge we bumped into is the cost of doing that, because the systems are pretty massive, for some use cases. Any tips on how to manage that?
Yeah, so we have a config system built into Pulumi. Because you have conditionals and things like that in the language, you can actually create smaller versions of your environments for purposes of ephemeral testing. So instead of having, 3 NAT gateways, spread across all AZs, which is going to be super expensive, maybe you have one, or maybe you skip that part of the architecture altogether for the mock environment. That's another approach. Some people mock some of these services. We tend to find that's really complicated because you might pass the test against a mock and then you go deploy to production and find a new issue. So usually it's better if you can afford to create a kind of approximation that's maybe a little bit smaller.
So what would a continuous delivery pipeline look like with Pulumi? I presume I would use something like Jenkins or Harness to build the code and create a plan and then automate the approval steps, or have some kind of way of deploying the code?
That's right. We made the decision early on not to try to create a separate sort of CI/CD environment that we were just going to integrate with existing ones. And so, Travis, Jenkins, GitHub Actions, GitLab pipelines, Azure DevOps pipelines, we've got, over a dozen of these integrations. And it works basically, what you're talking about. When you open a concept of a pull request. It's going to run the preview. And then once you've actually merged and committed, then it's going to run the apply. It gets kind of interesting. A lot of us, and this is how we do it internally too, we have actually different branches that map to different environments. And so when we deploy a new production version of a Pulumi service, we have a separate production branch. And so we open a pull request from the staging branch to the production branch. And then Pulumi knows how to do that sort of basically gradual rollout and deployment and diff between the two environments, which is kind of a nice way of modeling it. It maps well to Git concepts.
Very nice. Does Pulumi manage anything like, say, traffic rollover there? Because I'm guessing maybe you're spinning up a blue-green type situation where you're spinning up a new version rolling over, or maybe you're just, migrating a gateway or something. Does Pulumi integrate with any of that kind of traffic management? I'm thinking API gateway, service mesh, that type of thing.
Yeah, and where we can, we do. So, in Kubernetes, we actually sort of give you detailed updates as it's rolling out, about sort of where the traffic is moving to. And we sort of do mini blue-green deployments at the resource level. And so we prefer to spin up new infrastructure, drain traffic, and redirect traffic to new infrastructure before tearing down the old infrastructure. And so we've architected Pulumi to work in that way. And then if you're using like ECS, for example, we'll integrate with the health checking to make sure that task definitions roll out at the right time. And so we're trying to make it so that you don't have to think about it. Now there's like blue-green deployment at a much higher level. So for folks wanting to do zero downtime upgrades of Kubernetes clusters, for example, we have patterns that you can use to do basically blue-green at the entire Kubernetes cluster level. Some of this can be expensive, but if you really need zero downtime, there are ways to accomplish it.
That's an interesting use case. I definitely bump into that one a few times. And let's move on to a little bit of the bigger picture stuff now. I've heard you mentioned once already about sort of the multi-cloud situation. How important do you think multi-cloud is going forward?
I think it's reality for almost every company we work with. And it's for a number of reasons. I think multi-cloud can get a bad rap. I think some people assume when they hear multi-cloud that it means like trying to do lowest common denominator across all the clouds. And to us, that's not what multi-cloud is. In some cases, that makes sense, especially if you're doing Kubernetes, your workload can potentially be multi-cloud. But for us, it's really most large enterprises, the entire organization may have to deal with multiple clouds. There may be on-prem workloads, there may be Azure, there may be AWS in the mix. For SaaS companies like ourselves, we're selling to customers that may want to run our service in their own cloud. And that cloud is going to be AWS, Azure, GCP, or on-prem. And we don't want to limit who we can sell our own product to. And so it's in our best interest to think about multi-cloud. We have customers where they get acquired, right? And their parent company is an Azure shop. They were all in on AWS, but now they got absorbed into an Azure shop. And are they going to rewrite the whole workload overnight to run on Azure? Probably not, right? So now they're multi-cloud. They didn't plan on it, but they are. And so for us, multi-cloud is more about the workflow, the authoring techniques, the tools. It's not about lowest common denominator, but Pulumi gives you one workflow you can standardize across the organization, even if you're doing hybrid or multi-cloud.
Yeah, like the M&A thing, I've definitely seen that many times in big organizations. Like say I was in that situation, maybe I've got a bunch of Terraform code over here, some CloudFormation code over here, some scripts here, and I do want to standardize on my workflow. Is Pulumi kind of geared towards that? Is there a migration path, I guess, or an upgrade path of trying to bring everything together?
Yeah, and that's really important because most people have solutions for infrastructure already. So we allow you to either coexist with that stuff, either temporarily while you work through the transition or permanently if it makes sense. Maybe one team wants to keep using Terraform and the rest of the organization wants to use Pulumi. That's okay, right? Then there's ways to import infrastructure. So even if you pointed and clicked in the console, you can go and say, hey, take that under the control of Pulumi going forward. Third is we actually have translation tools. So we do have a tool that converts HCL to Terraform's HCL to Python or JavaScript or whatever language you'd like. And we have some for Helm charts and things like that. So got a good spectrum of options there.
Another thing I see a lot in the enterprise space is this notion of policy as code. You mentioned this a few times already. Would you mind sort of breaking some of that stuff down for the listeners? Because I think many folks think RBAC for authentication, but I think it goes much deeper than that.
Yes. Policy as code is the notion of, expressing policies like you can't expose an RDS database to the internet, or your RDS database must be MySQL version 5.7 or greater. And the idea is you can express these policies using a language Either a DSL in some cases, like there's an open policy agent, OPA, that has this DSL called Rego, which is more of a declarative model. Just like we did for infrastructure as code, we allow you to use your favorite language for policy as code. And then the idea is you then can enforce this and say, anytime somebody's doing a deployment, if it fails this policy check, block the deployment. And so we allow you to do that. We also allow you to say, hey, if I already have infrastructure, find all the violations I might already have. And then you've got a path to incrementally, maybe, remediating them and fixing them over time.
So let's wrap up now a little bit, Joe. I've really enjoyed the conversation. Lots to think about here, lots to research. I'll put some links in the show notes for sure. What's in the future for Pulumi? What can folks look forward to over the next, 18 months, say?
Yeah, I think, we're really excited because we shipped our 1.0 release in September, which was really a major milestone for us where we are sticking to compatibility. We know infrastructure is, the lifeblood of every business. And so we don't want to be making breaking changes. We're now ramping up to our 2.0 release, which is bringing policy as code and more testing tools and some of the things we talked about. And that's going to be out, pretty soon. Beyond that, I think, now we've got this really solid foundation. And we see a lot of patterns and practices that people struggle with. I mentioned the VPC case. Well, why would you write, 3,000 lines of code if you could have a real component with sharing and reuse? And so we're really focused in the future on, okay, let's focus on some of these patterns, some of these jobs to be done, make it really easy to just spin up an entirely new microservice in an afternoon, for example. So really now we've laid the foundation. Now, how do we use that to really improve the time to creating these things, reduce the boilerplate, really make it 10 times easier than it was before, thanks to, this foundation that we've put in place.
Maybe like a Docker hub for libraries type thing?
Yeah, totally. Today we rely on NPM and other module registries, but we're definitely looking at like, hey, can we have a central place for people to go to find all of these patterns and practices?
I think it makes good sense. And like Helm does it really well. The Rancher folks I know do it really well with their catalog. Docker have done it really well. I think for me as an engineer, like being able to reuse stuff is the power of where it's at.
Yes, especially as long-term, we want to make it really easy for developers too. Like infrastructure is still hard. Even though you can now use your favorite language, the concept count is really high for infrastructure. And if all you want to do is spin up a microservice, I want to use a Docker container, I want a serverless app, you shouldn't have to become an expert in all these things. And so that's kind of the next frontier for us.
Well said, Joe. Well said. So if people want to follow you online, what's the best way?
Yeah, so Pulumi.com, he's got all the goods there. It's open source. You can download it from there. We're on GitHub. I'm Funk of Joe on Twitter. If you want to follow me, we've got a Pulumi Corp Twitter account as well. But I would say just, download it. It's really easy to get up and running. I think most folks would be surprised how quick they'll be up and running if they give it a try.
Super. Well, thanks for your time today, Joe.
Yeah, thanks, Daniel. It's been great.